to each other here. Okay, so remember that last year we really focused in on quadratics. So remember when solving a quadratic, we're finding the solutions, right? We're finding where it crosses the x-axis if it does. So these are the solutions of the quadratic, -1 and 2. Another word for solving a quadratic is find the roots. So if I say find the roots of this quadratic, you're going to be solving it, right? If I say find the zeros, we're solving the quadratic. If I say find the x-intercepts, we're solving the quadratic. If I say find the solution, we're solving the quadratic, right? Everybody good with that? Okay, so remember, there's a few different types of solutions you're going to run into with quadratics. Look at the red parabola. It's crossing the x-axis in 2 different places. Now think about it, guys. Quadratics are degree 2, right? Degree 2. So with quadratics, once again, we're always going to have 2 solutions. The red parabola is an example of when we have 2 real solutions because it's crossing the x-axis, crossing the real number line here. This orange parabola, notice how it comes down, touches once, and bounces back up. Yeah, it's touching the x-axis once, but technically this is the parabola. Oops, let's get my pen. This parabola is x minus 1 times x minus 1. So we would get x equals 1, x equals 1, right? So if we solve, we would get x equals 1 twice. Even though it happens twice, it only touches down once. So in secondary math 3, we say we have 1 real solution with a multiplicity of 2, meaning it happens twice. Does that make sense? 1 real solution with a multiplicity of 2. Okay, and then also with quadratics, it might never cross the x-axis. That's when we run into 2 imaginary solutions. You have to have 2 solutions. Imaginary solutions come in conjugate pairs. So there will always be 2 imaginary solutions if it doesn't cross the x-axis. All right. Remember that quadratics have 2 different types of forms. Standard form, ax squared plus bx plus c, and vertex form, a times x minus h squared plus k. There's times when standard form's great. There's times when vertex form's great. I was just reminding you there's 2 different forms we're going to see today. If we have a quadratic in standard form, we're going to tackle solving it different than if we have a quadratic in vertex form. We'll get to some examples. Here we go. Look at your paper. Solve the quadratic. Notice on your paper it says, yes. Oh, okay, let me grab you one. So let's read the instructions. It says, solve the equation using either square roots, factoring the quadratic formula, or completing a square. Now, I'm not going to just accept you going through and solving them however the heck you want. Well, I am, but I'm not going to accept if you just go through and solve all of them with the quadratic formula. I want you to use the best method possible. So on number 2, I'm going to remind you how to factor. Now, yesterday, a lot of my secondary math 3 honors kids did not remember how to factor. You might have learned it differently than the way I'm going to show you, but get used to the way I'm showing you. And the nice thing is the way I factor this way. You can factor anything that's factorable this way. Mr. Roberts teaches it this way as well. So anyways, but you can factor anything like this. So watch very carefully. I had a few students say, oh, actually, that makes a lot of sense, and I like that. So here we go. So I'm going to do it kind of, so this one's an easy factoring one. So remember, my a value is 1, right? My b value is -6, and my c value is -16, correct? Ax squared plus bx plus c. One reminder, before you solve by factoring, you have to make sure it's set equal to 0. We're good. So then I say, this is how I factor. What multiplies to be a times c and adds up to be b. What multiplies to be a times c, so 1 times -16, and adds up to be b, which is -6. So factors of 16, right, is 1 and 16, 2 times 8, right? Everybody? 4 times 4. So which ones could possibly add up to be -6? 2 and 8, it needs to be -6, so it's going to be a -8, right? Now, our a value, this is where everybody understood this in my other secondary 3 honors class. My a value is 1, so we can see that this is going to factor to be x plus 2 times x minus 8, and it's still equal to 0. Now look, guys, if I redistribute, combine my terms when I end up back here, right? Isn't this where I'm going to end back up at? Okay, anyways, now our zero product property rule allows us to split those apart. Now that we've factored, we're solving, we're not stopping, we're not just factoring, we're solving. The zero product property rule lets us set each of our linear means degree 1, each of our linear factors equal to 0 and solve. So We set each of those equal to 0, so x is equal to -2 and x is equal to 8. Those are our two solutions. That's where it's crossing the x-axis, this parabola, right, everybody? Okay, awesome. Okay, while we're at it, I'm going to do another factoring one, and then we'll come back to this one. This one. I'm going to factor this one, because you can't just quick factor this one. That last example, if you just quickly factor this one, you're going to have to go about it the long way. I call it long factoring. Now, you can factor anything by this method. Okay, let's factor this one. Really quick, everybody pay attention, because a lot of people did not remember how to factor yesterday. So first of all, before we can solve by factoring, we have to make it equal to 0, right? And put it in standard form. So I'm going to subtract 15m from both sides, and I'm putting it in standard form. 4m squared minus 15m plus 14 is equal to 0. Now we can continue to factor, if it's factorable, to say what multiplies to be a times c and adds up to be b. Okay, a times c. So somebody tell me what's 4 times 14? Go. Okay, what multiplies to be 56 and adds up to be -15. Now we can list out all the factors, but let's think about it. Isn't 8 times 7 positive 56? And if they're both negative, won't that still be positive 56? And will -8 plus -7 add up to be -15? So those are our factors. Now look, that -15m, we're going to use to rewrite that -15m as these two factors. So this is where I call it drop and break. Drop and break. So this is what you always do, and factoring will always work this way. You can factor anything like this. You drop down the n terms exactly as they are. Drop. So we're dropping down 4m squared. We're dropping down 14. Right? Drop. And now we're breaking down that middle term. We're rewriting -15m as -8m and -7m. And the order doesn't matter. Is everybody following? Now we have 4 terms, and we're going to continue to factor by grouping. So we group the first 2 terms, we group the second 2 terms, and then we factor each group. So I'm factoring out the greatest common factor in this group. What's the greatest thing in common? 4 and a m. So now to see what's left in our parentheses, divide each term by what you factored out, because technically when we pulled it out, what we're doing is dividing it out. So left is m minus 2, correct? Looking at this group, what's the greatest thing in common? 7. And if there's a negative in front, a leading coefficient of a negative, you'll always factor out a negative. So we're going to factor out -7. So then to see what's left in our parentheses, we divide out -7. So then right here is a positive m left, guys? And isn't that 14 divided by -7 is? -2. Now I call this a safe haven. Do you see how these are the same? That's our safe haven. We say, phew, we've done this correctly. It's factorable. So if you don't have the same safe haven, 1, you didn't factor it right. 2, it's not factorable. One of the 2. Does that make sense, everybody? So our safe haven, we have 1 term, 2 terms. We factor out that safe haven because we have that in common in the first term and second term. So we factor out n minus 2. So then to see what's left, we would divide that out, right? Because that's what we factored out. And left is 4m minus 7. Now that is factored. Does that make sense, everybody? It's kind of a process, but I don't teach tricks, really. But because if you do this, you'll factor it right every time. Now the 0, it was 0 up here. This was in standard form. It was set equal to 0 up here. This is now in factored form, so it's still equal to 0. So the 0 product property rule lets us set each of those equal to 0 and solve. So when we get m equals 2, set that equal to 0, we'd add 7 divided by 4, right? M is equal to 7/4. Is everybody comfortable with factoring? I had to go through that a little bit slower than I did yesterday because people did not know how fast. Are we more comfortable with factoring? Okay, so that's solving by factoring. If I can solve by factoring, I always choose that method. Okay. All right, so I think, oh yeah, let's do this one. So I'm going to do number 2 really quick. I don't want to steal all your examples by completing the square. How many of you probably need a reminder of completing the square? Most people, right? Okay, so quickly, let's review this. So first of all, notice my A value is 1. So completing the square, if your A value is not 1, is a little different. So what we do is we're going to find the value that we can insert this in. We're going to manipulate this equation to our advantage to put it from standard form to vertex form. And we do that by completing the square. So what we're going to do is we are going to insert some number right here that's going to make this factor to a perfect square. So how you find that is you take b divided by 2 squared. So my b value is negative 6, right? Negative 6 divided by 2 squared, so negative 3 squared is 9. So I'm going to add 9, right where I put that star. I'm going to add 9 to this side of the equation. Now I've added 9. I've changed the problem. That's not okay. We don't just get to change problems. But if we do it to both sides of the equation, we're good, right? We just manipulated it, not changed it. So I'm going to add 9 to both sides of the equation. Now I'm choosing to put 9 right here for a reason. So I'm rewriting this really quick. X squared minus 6x plus 9. We still have our minus 16, and that's equal to 9. So then we group these first 3 terms, and we say, okay, that factors to be a perfect square. Now here's why. What multiplies to be 9 adds up to be negative 6. Isn't that negative 3 times negative 3? So this factors to be x minus 3 times x minus 3, right? Which is a perfect square because that's x minus 3 squared, right? Now look, there's a trick. You can look back inside. The reason we do b divided by 2 squared is because that's what's going to help us know what to factor it to be. So it's going to factor to be x minus 3 squared. We still have our minus 16, and that's equal to 9. You see how we went from standard form to vertex form. Now we solve vertex form by the square roots, by taking square roots. So we isolate x squared. So we get that alone. We add 16. So we have x minus 3 squared is equal to 25, right? So what we do next? Square root both sides of the equation. So we have x minus 3 is equal to what? 5. Somebody said something. What? Plus or minus 5. Because remember, guys, square root really technically means what squared equals me? What squared equals 25? 5, but also negative 5. So we write plus or minus 5. Then we split it apart. X minus 3 is equal to 5. X minus 3 is equal to negative 5. We solve for x in each case. Add 3, x is equal to 8. Add 3, x is equal to negative 2, right? There's our 2 solutions, but did you see why we would choose factoring over that method? Because that was unnecessary hardness, right? I was just reviewing with you. Okay, awesome. Okay, do we need a reminder of the quadratic formula? Are you good?
Yes.
Are you sure? Even with imaginary solutions, breaking it down, pulling out. Is that? So I don't want to stand up here and do it if you're good. Tell the truth. If you want an example, raise your hand. Okay. So before we do the quadratic formula, and then I'll let you practice. Right after this, I pinky promise with cherries on top, okay? Here we go. We get it set equal to 0. We put it in standard form. 12x squared minus 9x plus 6 is equal to 0. My a value is 12. B is negative 9. C is 6. So then we have our quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to sing you a quick song. How many of you learned this song to Pop Goes the Weasel? Yeah. Okay. So it goes like this to remember the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I know you thought you were actually at a Taylor Swift concert, but you're not. You're in my class. Okay, should we all sing it? Yes. Too bad, even if you don't want to. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's plug it in. I want your calculators out. Let's calculate this quick in a second. So x equals the opposite of b, which is positive 9. Plus or minus, right? Are we following? I'm going to change colors. Plus or minus the square root of b squared, which is negative 9 squared, minus 4 times a, which is 12, times c, which is 6. That's all over 2 times 12. I'm going to simplify again. Somebody go calculate underneath the square root for me. 9 plus or minus what's under the square root. Let's all calculate it. Make sure when you type this into your calculator, you use parentheses. What is it?
-207.
-207. Okay, now remember, this is where we go off to the side and say, okay, I need to continue to simplify. I'm going to simplify this section. -207, I'm going to ignore the negative for right now. We know that's where our I comes from, but we're going to ignore it for right now. What are some factors of 207? Go, go, go. Factors mean what multiplied to be 207. What are some factors? Any factors? 9 times? Okay, so tell me what the other factor is. That's great. What? 9 times 30? 9 times 23? 9 breaks down into 3 times 3. These are prime factors. So we pull out groups of 2, because really we're doing the square root of 9, right? Which is 3, so that's why we pull out a 3. This is left under the square root, because we can't pull it out. We pull out an I. So this piece simplified to be, so we have 9 plus or minus, we have a 3, we have an I. On the outside, left under the square root is 23, and that's all over 24. Yay, there's our answer. However, we check to see if all three, only if all three of them divide by something in common can we start dividing things. What do they all multiply by? I mean, what do they all divide by? 3. Okay, they divide by 3. This divides by 3 and becomes a 1, becomes a 3. This divides by 3 and becomes a 8. So our final answer is 3 plus or minus I square root of 23 all over 8. There's our two imaginary solutions. Whoa, we're so cool. Okay, ready, practice, practice, no, practice, go. Okay, so pay attention, guys. You've got to be expert factorers. So it's quadratic, it's equal to 0. I say I'm going to try solving by factoring if it factors. So we're looking for what multiplies to be A times C and adds up to be B. So we're looking for what multiplies to be 12 and adds up to be 8, right? So wouldn't that be what?
4.
6 times 2, right? And they're both positives. It needs to multiply to be positive 12, add up to be positive 8. So we check. Yep, it works in both cases. Now we drop and break. We drop down our end terms exactly how they are. Sign and all, sign and all. So we have 2x squared. We have a plus 6. You drop. Now we're going to break. We break down the middle term. We're rewriting 8x as 6x plus 2x. Does everybody understand how that's the same thing as 8x? Now, order doesn't matter. So we could say plus 2x plus 6x, and that's what I'm going to do, but it doesn't matter. We could have switched those. Now look, 1, 2, 3, 4 terms. If we have 4 terms, we factor now by grouping, they call it. So we're going to group the first 2 terms. We're going to group the last 2 terms, including that sign. Then you're going to look at each group, pull out the GCF, greatest common factor. In common here is a 2x, so look, I write it. Now I'm going to put what's left inside my parentheses. If you need to write the 2x being divided, do that. So we have x plus 1, yeah? Now we're going to factor out of this group what's in common, 6, and we're factoring out positive 6. We'll always factor out that sign. Positive 6, right? Watch, this is where some of you are getting confused. I'm pulling out positive 6. Now I'll divide each term by positive 6. Left is x plus 1. Now this is what I don't think some of you, because of the way you're asking me the question, I can tell some of you don't understand something. So let me show you. Terms are separated by plus or minus signs. Here's a term and here's a term, right? Now what's in common in each term?
X plus 1.
Can we factor out common terms?
Yes.
So that's why we're going to say, okay, we have our safe haven, we're going to factor it out, because that's what's in common. We're factoring out x plus 1. Now let's divide each term by x plus 1 to see what's left in our parentheses. So, gone, gone. Left is 2x plus 6. Now, if we were factoring, we'd keep going, because doesn't a 2 factor out?
Yeah.
But we don't need to do that because we're solving. We just set each of those equal to 0 and solve. So we get x is equal to -1, and x is equal to, we subtract 6 divided by 2, right? -3, guys, you're, make sure you can factor. If not, go home and watch this video a couple times tonight, okay? All right, continue. I would love to help. So, this is an example of a perfect square trinomial, meaning this will factor to be a perfect square. Now, here's why. If we factor this, we're looking for what multiplies to be a times c, what multiplies to be 1, and adds up to be -2. 1 times 1, won't they both be negatives? Yeah? Right? So this is going to factor to be, we can quick factor it because our a value is 1. So this is going to factor to be x minus 1 times x minus 1. So really this factors to be x minus 1 squared, right? So this positive 1 made this a perfect square. So I'm going to ask you a question now. What value makes this a perfect square trinomial? Go, top tier group. Go, what do you think? What do you think? It's okay if you're wrong.
1 before was 2.
Okay, does anybody want to shout out an answer? If you're on the okay. Okay, we get a 7 over here. I'm going to put some answers over here. Anyone else get a different answer? Oh, I got a 49. Anyone gets okay. No, that's great. Anyone else get anything different? Okay, yes, you're right. It is 49. Now here's why. It's okay. So you 7 people out there, it's okay. So here's why. Don't we know, are we looking for what multiplies to be 49 and adds up, no, what multiplies to be a times c adds up to be b, so, and adds up to be negative 14, won't that be negative 7 times negative 7? Yeah? So this would have factored to be x minus 7 squared. Now, a different way to think of it is completing the square. Can you just take b divided by 2 squared to figure out what's going to be that value? Yeah, our b value is negative 14 divided by 2 squared, which is negative 7 squared, which is 49. So do you see how we got that, sir?
Yeah.
You do? B divided by 2 squared, right?
Negative 2x.
No, yeah.
So I like just half it.
No, I can see how you did that.
Yeah.
That's what actually a lot of people my first time did it. That way. Okay, do 14 through 21 and 27. Skip to that. Skip to that. Guys, pay attention. This shouldn't be new, but some people, it's been a long summer. So it says, write a quadratic with the given root. So instead of given the quadratic, find the roots, we're given the roots, we're given the zeros, and asked to find the quadratic. So if I give you a picture, we would say, okay, what's this quadratic? Well, isn't this the solutions? So we know our solutions are x equals 2, and we have a solution x is equal to negative 1, correct? Now, if those, think about it. Okay, listen till you understand, not just go through a process. Okay, understand something. If these were our solutions before we had solutions, didn't we have linear factors? Linear factors means degree 1. Weren't they equal to 0? Yes. So instead of equal to 2, we need it equal to 0. So wouldn't we subtract 2? So if we have a solution x equals 2, x minus 2 must have been the linear factor, right?
Yeah.
Does that make sense? If x is equal to negative 1, if that's true, then x plus 1 must have been the linear factor, right? So we're going backwards. Well, before we were able to split them up, they were together being multiplied and equal to 0. The zero product property rule is the reason we're able to split them up. Does everybody see what I'm saying? Yo, we're all good? Now, that's the quadratic in factored form. That is the quadratic, but I want it in standard form for today. So we would distribute x squared plus x minus 2x minus 2 is equal to 0. So this was the quadratic with these solutions. Do you see how we went backwards? Yes. Okay, another example, a little bit more difficult. Questions, please ask. Yes, sir?
How would A
How would A?
Yeah.
What do you mean A? That's a good question. It would have just been this. X is equal to, let's say this was a fraction, let's say 3/4. Let's make this what linear factor? We would multiply both sides by 4, right? To get this equal to 0. So that's 4x, right? Do you see that? So we have 4x is equal to 3. Let's say that 3/4 was our solution, and then when we subtract 3, so do you see how it would be if you have a fraction? Does that make sense? Great question. I'm actually glad you asked that. I know I thought about it. If they say, ask that one more time.
So if
Yes. Good question. All right, so I want to remind you of something. Quadratics have two solutions. You can never just have one imaginary solution, one real solution. It doesn't work that way. Imaginary solutions come in conjugate pairs. So if x is equal to 3i is a solution, then x is equal to negative 3i is also a solution. Remember, conjugate just means change of sign in between. You see how those are conjugate, change of sign in between. So if x is equal to 2 minus I is a solution, then x is equal to 2 plus I, the conjugate, is also a solution, for sure. Now that's also true for irrational roots. Irrational means cannot be written as a fraction. So if you have an irrational root, then its conjugate must also be a root. So this is an example of an irrational root, 1 minus the square root of 2. So its conjugate, 1 plus the square root of 2, must also be a root. Okay, let's use that to answer this. Write a quadratic with these given roots. So we're going to go backwards. X is equal to negative 2i, so what's the other root? X is equal to 2i, so let's go backwards. Before we had solutions, we had linear factors. So we'd add 2i to both sides. They used to be equal to 0, so we have x plus 2i is equal to 0. That was the linear factor before we solved. So we'd subtract 2i from both sides. Do you see how that adds up to be 0, guys? Okay, so we have x minus 2i equals 0. Before they were split apart, they were multiplied together. X plus 2i times x minus 2i. And now we're going to double distribute. It's been a long, long summer. X squared minus 2ix plus 2ix minus 4. Are we paying attention to this part? Positive 2i times negative 2i is negative 4i squared. Now look, with conjugates, the conjugates, middle terms will cancel out always. So we're left with x squared minus 4i squared. Does anyone remember what I squared is equal to? So technically we have x squared minus 4 times I squared, so we really have times negative 1. Very good. So the quadratic is x squared plus 4. Now look, if we solve that, wouldn't we subtract 4? And then we square root it, and we get plus or minus 2i. Do you guys see how you're going backwards? If not, raise your hand or ask for further explanation. Okay, so I'm not going to go through this one, but if x is equal to 3 square roots of 2 is a solution, then x is equal to negative 3 square roots of 2 is also a solution. Then we do the same process, right? Okay, do you want me to do one last example and then the rest of the time will be yours and then you can take the rest home for homework? Yes. Yes. Yep. Okay, everybody, write a quadratic with these given roots. This one's way, a lot longer. Can we quickly go through it? So if this is a solution, x is equal to negative 1 plus 2i, that's an imaginary solution. The conjugate x is equal to negative 1 minus 2i is also a solution. Remember, conjugates are only change of sign in between. That's why it's still negative 1, right? So now we're going to make it equal to 0. Watch, there's a little bit more to this one, a little bit more We'd add 1, subtract 2i. We're making it equal to 0. Add 1, subtract 2i. So we have x plus 1 minus 2i is equal to 0. Comfortable? You're sure? No? Okay. We add 1 to both sides. We subtract, nope, add 2i, right? Guys? Yeah. So we have x plus 1 plus 2i is equal to 0. Now they were multiplied before they were split apart. Sorry. X plus 1 plus 2i, they were multiplied together before they were split apart. Be very careful, this is triple distribution. Lots of room for errors. You will have one like this on our upcoming test. X times x is x squared. X times 1 is 1x, yeah? X times 2i is positive 2xi. 1xx, same thing, yeah? Yeah, so I don't care how you write it. That's totally fine, though, if you want to write just x. And then we have 1. I'm going to distribute 1 through. 1 times x is x, right? I'm just writing a 1 in there for now. 1 times 1 is 1. 1 times positive 2i's is plus 2i's. We're not even done yet. But this is awesome, right? You feel like a bad A. Okay, Negative 2i times x is negative 2ix. Go show your parents this problem and they're like, oh, you're cool. Negative 2i times 1. Yeah.
So, x times 2i.
It actually doesn't matter. You could put 2ix or 2xi. So we have negative 2i times x, which is negative 2ix, or 2xi, same thing, actually, good question. Negative 2i times 1 is negative 2i's. And negative 2i's times positive 2i's is negative 4i's squared. Okay, guys, let's combine all like terms so that we don't have such a mess here. X squared, any other x squareds?
No.
X plus x is 2x's, yeah? Positive 2xi's minus 2xi's, or ix's, same thing. Cancels. We have plus 2i minus 2i. Cancels. Plus 1. And then we have minus 4i squared. So isn't that the same thing as negative 4 times negative 1?
Yep.
So isn't that plus 4, guys?
Plus 5.
Yeah, plus 5. So the guys, the quadratic that had those solutions clear up there was x squared plus 2x plus 5. That would have been the quadratic, and if we would have went through and solved it using the quadratic formula, we would have got those solutions. Do you understand that?
One more question.
Cool. Yes. Yes.
How does that sign?
Good question. We had a plus 1 and then plus 4. Great question. Oh, good question. Okay. So if I said to you, so, okay, this is what somebody came in and asked me this morning. She said, well, okay, look at the very last part of your thing. It says, find the zeros of the polynomial function, then write the polynomial as the product of linear factors. So don't you just solve it and then work backwards and stop at linear factors? Do you know what you're doing for that problem? Read the directions real quick. Do I need to elaborate? Read it. It says, find the zeros. So doesn't that mean solve?
Yeah.
So let's say I went through, so I will go through and solve. Let's say I solve and get x is equal to 3i, and let's say I get x is equal to negative 3i. Okay? Now the second part says, write the answers as the product of two linear factors. If those are our solution, what were the linear factors? Nope, x, right, minus 3i?
Yeah.
So we have x minus 3i was a linear factor, yeah? And then plus 3i?
Yeah.
So the other linear factor was x plus 3i. So we solved, boom, rewrote it as a product of two linear factors. Yes. Yes.